So coming to Coulomb's law, Coulomb's law is similar to somewhat or is somewhat similar to gravitation. Okay, gravitational universal law,
Yes.
inverse square law. Okay, the force Coulomb's law says that 2-point charges, the force between the 2-point charges is directly proportional to product of charges and inversely proportional to square of the F is equal to K Q1 Q2 by R square is the formula of it. But the point is, if you remember here, is it is for point charges, not any bodies. Okay, wherever you see different kind of bodies, you cannot directly apply K Q1 Q2 by R square. These are for point charges. Okay.
Yes, sir.
So if it has to be written in the vector form, F is equal to K Q1 Q2 by R square into R cap. Okay, along the line joining the two charges. So here, if both are same charges, then they will repel each other. The force will be away from the charges.
Yes, sir.
If both are opposite charges, this there will be minus. One will be positive, one will be minus. This product will be negative. So that then they will get a negative sign, which is an attractive one, because towards the inside to opposite to the radius. So suppose if two charge Q1, Q2 is there. This is R vector. So suppose if both are same charges, the force will be repulsive and the force and the radius vector in the same direction. If opposite charges are there, force will be attractive. Force will be attractive and force will be attractive and the radius will be, so that is a minus you will get, because sign of the charge is important here. You have to substitute.
Yes.
Okay, vector form. This can also be written as F is equal to in vector form K Q1 Q2 by R square into R cube into R vector. Okay,
Yes, sir.
here there will be two kinds of forces. F12, but the force on 1 due to 2, like that F21 force on 2 due to 1. They will be opposite to each other. If first charge is attracting the other body, the force will be like this. Second charge also will attract the first body. That force will be like this, right? Both are in opposite directions, right?
Yes, sir.
So that F21
Yes, sir.
is equal to minus of, it will be opposite to it, minus of F12. But magnitude wise, both are same.
Yes, sir. Sir, this is R square, no, sir?
R cube. When we write
This
here
one,
is R vector, then it will be R cube.
yes, sir.
Why R cap is unit vector, that is equal to R vector by magnitude of R, right?
Yes, sir.
Instead of R cap, I substituted R vector by magnitude of R, that is R cube.
Okay, sir. Okay.
So that is why you will get R cube if you write it as R vector. Okay. Then here comes
Yes, sir.
K.
Yes, sir.
This K is equal to 1 by 4 pi epsilon naught. Is that constant? That is equal to 9 into 10 power 9. Someone asks you Newton meter square per Coulomb square.
Yes, sir.
Answer. Epsilon naught value is 8.85 into 10 power minus 12, right?
Yes, sir.
8.8.
I don't know, sir, actually.
Huh?
I don't know epsilon naught value, sir.
As far as I remember, this is 8.85 into 10
Yes.
power minus 12. This value is 8.85 into 10 power minus 12. Unit we can write here like this. Uh, Unit of this one fr square by q square. Sorry. Okay. K unit is there, right? Fr square by q square is K unit. Opposite
Yes,
to
sir.
it. That is Coulomb square by Newton meter square. Got it?
Okay, sir.
K is 1 by 4 by epsilon naught. Epsilon naught is equal to 1 by K, right?
Yes, sir.
So opposite to this, Coulomb square per Newton meter. Okay.
Yes, sir.
And if there is multiple point charges, so suppose one charge is influenced by many other charges. So one F, second charge, third charge, and fourth charge. So this one F1 vector plus F2 force on our charge due to first vector plus F02 vector force on our charge F0. So due to second charge, force on our charge that is required, not zero charge, 2 by second charge, sorry, third charge. Like that, we can create the vector sum of all the charges, all the forces to be the force on the charge. Okay.
Yes, sir.
Then one of the example you can write it as, take a question. So four equal charges are placed on equal charges are placed on the four corners of a side of a square. Four charges of the side of a square. Then what is a force on this charge? Force on this charge. Net force on this charge. One corner charge. This one. Okay. Four are identical.
Yes, sir.
You can solve. I'll explain.
Sir, I can't hear you. You unmuted, sir.
Okay. No. The point is, I asked you the force, net force on this charge. So on this charge, what are the forces? Three charges are there. Three other charges are there. Who can apply force on this charge?
Yes, sir.
Due to electrostatic force. So this charge will
Yes, sir.
repel this charge because identical charges it. So
Yes,
that
sir.
this charge will
Yes, sir.
again repel this charge, and this charge also will repel like.
Yes, sir.
But because they are identical charges, force due to this charge and force due to this charge should be equal in magnitude, not in direction. So there are three
Yes, sir.
charges of this forces of this sort. I can consider this as F1 magnitude, but direction is different. This I am considering it F2 vector. So because they both are equal charges, exactly the resultant will be exactly midway, right? In the
Yes, sir.
direction of F2. So the net force will be F2 vector F2 plus magnitude wise F2 plus root 2 F1. Got it?
No, sir.
No?
No, sir, I couldn't get you.
So both the vectors are perpendicular to each other and equal. That is root over F1 square plus F1
Yes, sir. F2 whole square. F1 whole square. So
root
2
to
F1 whole square.
root to F1, but exactly
Okay.
because they're equal, exactly they will be along this line, mid line,
Yes, sir.
along this force line. So
Okay,
both are
okay.
the
Got
same
it, sir.
direction
Got
we
it,
can
sir.
add, right?
Yes, sir.
So like that. So F2 is what? F2 is equal to K Q1, that is Q square, KQ square divided by distance is what? If this is A, this will be root 2A, right?
Yes, sir.
Root 2A whole square, that is F2 plus root 2 into F1 is what? KQ square by A square.
Yes, sir.
KQ square by A square. So now what is the answer? This is an important question also. So KQ square is common. The answer will be by
Sir,
A.
actually, what did you do, sir?
Vector
I
net.
know, I understood the diagonal is root 2a.
Uh,
And you took the force between this charge and the opposite charge, no, sir?
uh,
Uh, R whole square, root a whole square, okay. And how about this, sir, root 2?
this root to F1. F1 is due to these two charges.
Okay, okay, okay. I got it, sir.
So 1 by 2 plus root 2. The answer is KQ square by into root 2 plus 1 by 2. That is the answer. A square. Got it?
Yes, sir.
So sorry. 2A square. This will be root 2. 2 root 2. 2 root 2 plus 1 by 2.
Yes, sir.
So you understood how I solved this problem?
Yes, sir, got it.
Another point to be understood is if K will become 1 by 4 pi. If that net force will become 1 by 4 pi epsilon not I wrote right into
Yes, sir.
epsilon r q1 q2 by r square.
Yes, sir.
1 by 4 pi epsilon r q1 q2 by r square. When it is kept in another medium of uh, relative permittivity of medium, that is
Or like when it is placed in any medium, then we need to consider ER, no, sir?
I'll tell you. Epsilon r is now equal to epsilon by epsilon naught. Epsilon naught is the permittivity of the free space. Epsilon is the permittivity of the medium that you kept. Then epsilon r is the ratio of permittivity of the medium to the permittivity of the free space. Then epsilon is equal to epsilon naught epsilon r. Got it?
Yes, sir.
So now epsilon naught epsilon r. Now going forward, uh, this force is equal to and the quality point I'm trying to say and I did not say. No, I replaced this epsilon with epsilon naught epsilon r. Did you understand here?
Yes, sir.
But one point to remember: if someone asks you a question of this sort, what is the force? Now, if you calculate this one, what will it will become? Suppose if I want to calculate this force is equal to 1 by 4 pi epsilon naught epsilon r q1 q2 by r square can be written as 1 by initially when there is no medium, only free space is kept, that force divided by epsilon r also, right?
Yes, sir.
Because 1 by 4 by epsilon naught q1 q2 by r square is that force in free space, right?
Yes, sir.
Now you carefully see this epsilon r also can be written as dielectric constant.
Yes,
That
sir.
is f by k also we can write.
Yes, sir.
If someone asks you free space in medium, what you will do, someone asks you what is the interactive force between the two charges initially when it is in free space is F. What is the interactive force? Interactive force between Q1 and Q2 with the distance of R is F in free space, okay? F,
Yes, sir.
magnitude F in free space. Now what is the interactive force due to charges Q1, Q2 in another medium? Got it?
Yes, sir.
Tell me.
So in the first case, when it is in air, it will be
Yeah, I
1 by
gave you F.
epsilon.
F.
Yes, sir. Okay, F. F divided, in the second case, F divided by R naught.
R not or
Sorry,
K?
ER.
ER or K,
ER.
right?
Yes, sir.
but that is wrong. Like,
ER is equal to K, sir. How, sir? How is ER is equal to K?
epsilon r, that is nothing but dielectric constant only. Relative permittivity is nothing but K is not that K, 1 by 4 pi epsilon r. K is dielectric constant. Sometimes dielectric constant is also described by K.
Yes, sir.
Okay, in materials.
Okay.
This K is not that K, that is 1 by 4 pi epsilon r. That is different.
Yes, sir.
This K is nothing but epsilon r. But actually, this answer is not F by K. Why? Because I'll tell you. The interactive force will not change now also. Q1 on Q2
Yes,
and Q2 on Q1, that interactive force will not change. Will not change. But,
yes, sir.
but what will change is net force. Why? Because there will be a material here. Why? Because the material which is present here, some dielectric material, that is another medium. Due to this medium, suppose this medium also will apply this force on this, right?
Yes, sir.
So due to that, this force will change, decrease. You did not get this point?
No, sir.
A, this is B, two charges, and there is a C medium, okay?
Yes, sir.
This force will become F by K now due to the C medium, not due to
Yes,
B,
sir.
right?
Yeah, no, yes, sir. I get. Yes, sir. True, sir.
So the interactive force between Q1 and Q2 is same now also. But why this force F by K has become? Not because of this interactive force, the change in interactive force. Because of the introduction of the medium also will get ionized. Suppose if it
Yes,
is
sir.
positive charge, so medium also positive, it will get ionized as here negative, positive, negative, positive.
Oh, okay, okay, sir.
Because of
Yes,
this
sir.
medium, that force will get decreased. So initially what is happening? This force is repulsing, but now medium is getting ionized and what it is attracting to some extent, right?
Yes, sir.
Is the force decreased or not? Net force on this charge.
It's decreasing, sir.
So like that this F by K has come, but interactive force between the two charges now also it is same. 2 or 3 years previous, one of the previous years.
Yes, sir.
This kind of question is also asked. That's why I tried to touch that fundamental point.
Yes, sir.
You will not generally find that in materials. Okay. Got it?
Yes, sir.
Next. So this is the whatever I taught now is more about point charges. But if it is not point charges, how our story will be created? It is difficult, right?
Yes, sir.
Our story has to happen. So even for other bodies. So there comes the story of electric field electric field intensity. Electric field intensity. What is that electric field intensity? The suppose any charge is there, any random shaped charge is there, or point charge is also there. The field intensity due to this body at a point P at a distance of R is our electric field intensity. Got it?
Yes, sir.
So you can ask me, so what is this field intensity? Suppose if what it is nothing but per unit charge, force per unit charge at this point. Got it?
Yes, sir.
Electric field intensity. You can ask me what? For example, I'll tell you. So point charge is there, right?
Yes, sir.
To make you understand, simply I'm explaining. Q1, Q2, distance is R. So now the force magnitude is what? K Q1, Q2 by R square, right?
Yes, sir.
That is equal to the force. Now I am asking the field due to Q1. Field due to
Q1.
at this point. Okay.
Yes, sir.
So then here, for if Q2 charge, if you kept the magnitude of force is KQ1 Q2 by R square, right?
Yes, sir.
For unit charge, how much will be there divided by Q2, right?
Yes, sir.
Right? Per
Okay.
unit charge, matlab, for Q2 charge, it is KQ1 Q2 by R square. Per unit charge is what? KQ1 Q2 by Q2, right?
Yes, sir.
Q2 Q2 get cancelled. The
Yes,
answer
sir.
is KQ1 by what? R square.
Yes, sir.
That means the force due to charge Q1 is the field due to charge Q1 is KQ1 by what? KQ1 by R square. Got it?
KQ1.
So
Yes,
what is the
yes, sir.
advantage of finding out this field, sir? If you know the field, force can be F by Q is equal to E, right? So if you know the field, F is equal
Yes,
to
sir.
EQ. Got it? In number of situations, if that
Yes,
field
sir.
intensity is known, so you can easily write a force. Okay,
Yes, sir.
got it?
Yes, sir. Sir, here is electric field intensity, no, sir?
Ah,
Okay.
now for point charge, you got it as what? Just you solved here, KQ by R square, right? At a point.
Yes, sir.
So this is the field intensity for a point charge. But but other bodies also we need to write, at least for NEET level, we need to learn about sphere.
Yes, sir.
Hollow sphere if they ask. This will be again repeated in gravitational. Hollow sphere if they ask, that will be K hollow sphere which has Q charge distributed uniformly distributed over it. What I will take is 3 points I need to consider. One point is one point is at the outside point with the distance r. One point is on the surface. One point is inside the surface. Okay.
Yes, sir.
So now outside point is k. When it is outside point for solid hollow sphere, what we can do is you can consider that entire charge to be present at what? Center.
Center.
So k q by r square is a field intensity E outside.
Yes, sir.
If you want force at that point, if you keep any charge, you multiply with that charge, you will get the force. Okay.
Yes, sir.
Now E surface is also k q by capital R square. Okay, because R is the
Yes, sir.
radius. But for inside, E inside is actually 0.
Sir, here we considered E because intensity, and we consider 1 point. Yes, sir, I got it. But
Inside
yes,
point,
sir.
why it is this is, you cannot consider that as a point charge present at this point because effectively the entire charge is outside field. You just consider it in this way because I am not going to explain all the relevant information why it is
Yes, sir.
taken like that. No effective charge present.
Yes, sir.
Similarly, gravitation
Yes,
also
sir.
will have the formula hollow spherical mass. So gravitational field intensity is G m by r square outside surface point G m by capital R square minus r cap you will get because it is attractive force. So uh, inside point for also will be 0. Got it? Effective mass is 0 inside.
Yes, sir.
Okay.
Yes,
So
sir.
if
Got
someone
it.
gives you any charge and asks you what is the force here, it will be 0 for hollow sphere. Okay.
Yes, sir.
Then solid sphere. solid sphere.
Yes.
Solid sphere, it acts like entire charge. You can consider it as, you can consider it to be at the center, its center of mass. When you have to find out electric field at a point outside. Outside.
Yes, sir.
Surface is also similar. You can consider the entire charge to be present at the center, but not inside point. Got it?
No, sir, I couldn't get you.
Huh?
Sir, can you repeat what you said, sir?
For outside point, entire charge. This is solid
Yes,
sphere.
sir.
Entirely charge is distributed over the body. Okay.
Yes, sir.
Entire charge can be assumed to be present at what? That center. For an
Yes, sir.
outside point, that means your field will be, intensity for outside will be kq by r square.
Yes, sir.
R cap. But surface point also we can consider that to be entire charge to present at the center. The value will be kq by r square. Okay. But you cannot consider inside point. Now you cannot consider it is zero because some charge is inside, right? Effectively.
Yes, sir.
Point. So you need to find out that charge. How to find out charge? That q is distributed over entire 4/3 pi r cube into that small volume 4/3 pi into r cube. Got it? Is a
Yes,
charge
sir.
inside that particular volume. The charge will be q by r cube into small r cube. Got it? So now
Yes,
I
sir.
inside will be, sorry, I not, E you can mention, E outside, E surface. So K into Q dash is how much? K into Q dash by R square L, right? That Q
Yes,
dash
sir.
is how much? K into Q by capital R cube into R cube divided by small r square. R square will go by one time. Are you getting this or not?
Yes, sir.
No?
Uh, Sir, it's like the 1 second, sir. So- And sir, this is the whole char and q divided by 4/3 pi r cube.
This is density.
Capital.
This will be density. Density into volume I'm finding out to get the effective charge, effective charge inside that particular volume.
Yes, sir. Density is equal to mass by volume, no, sir.
That
So if
is,
we
this is charge density.
okay, then it is charge density into volume. We'll get charge. So
That
q
charge present
divided.
inside that charge, inside this point,
Yes, sir.
effectively. This
And
outside charge, you can consider that force to be negligible. Negligible, you can neglect that force. Okay.
and why this one, sir?
So we are
How, sir?
electric field due to that outside charge, you can consider it to be zero. Why? Because I taught you right. If a shell is there, inside the shell, the field is what? Zero.
Zero, sir.
So now, can you consider this as one shell and other shell, third shell, fourth shell like that?
Which one, sir? I couldn't get it.
Solid sphere is a combination of shells, right?
Yes, sir.
This outside shells, inside a point. This point is this for this point P, so otherwise
Yes,
R.
sir.
All the other shells are outside, right?
Yes, sir.
Due to outside charge, the field will be zero. Due to inside charge, the
Yes.
field will be there. That field will be. You understood this? Q dash by R square. That Q dash has come to be Q by R cube.
Yes, sir.
Q by R cube. And divided by this one is R square, like in normal formula, into R cube. This R cube. So now R square goes by R in R cube by one time. So that is KQ R by R cube. Did you get this formula or not?
Yes, sir. Got it. Now.
This is an important formula. Now, very important. Sometimes in NEET generally they'll give diagrams directly. You see, sorry. For a hollow sphere, electric field inside, electric field and position. So inside it is zero, right? Till the radius, till the surface, right?
Yes, sir.
So then the
Sir,
graph.
here the radius is capital R and the point where we consider is smaller, no, sir?
Small r outside also, inside also I'm considering R only, general point R.
So the shell's radius is a capital R.
Shell's that entire shell radius is capital R.
Okay.
So this one R, because it is inversely proportional outside, that is, it is R square, R square. So this is inversely proportional, like this graph will be there, got it?
Yes, sir.
And inside will be 0. Inside will be 0. And for solid sphere, that is purely distributed over this volume, the value will be like this, because it is directly proportional to R right inside the surface. And outside the surface it will be like this. So these graphs are asked in few exams that directly you can tick.
Sir, the first graph is like for what, sir?
Hollow sphere,
Yes, sir.
or you can write it for conducting sphere also. Conducting sphere, entire charge will be outside only.
Yes, sir.
Here non-conducting sphere, uniformly distributed charge.
Yes, sir.
And our entire volume, non-conducting sphere, or uniformly distributed charge, uniformly distributed over volume. Got it?
Yes, sir.
Did he send you electrostatics first lecture in the recording? Did I?
No, sir. You taught only one first chapter, session, sir. Then you took an off.
I got it. But did I send you that lecture in the group?
Yes, sir. You sent, sir. Sir, I have a small doubt. In the first one is like.
Right.
Yes, sir. Got it.
This is graph. And sometimes, okay, this is graph. Gravitation also, these two graphs will be there, right?
Yes, sir.
But in gravitation, what you need to understand is, if they might give you like this also. What is this? Like this. Because gravitational field is an attractive force. So there will be a negative symbol, right? Due to attractive force. This might be the graph. Got it?
Yes, sir.
Reverse to this. Just I say change it in the sign in the fourth quadrant again. Got it?
Yes, sir.
This value here is minus gm by r square. Here the value is gm by r square. That is minus gm by r square. You got it?
Yes, sir.
Gravitational field intensity for hollow sphere, for solid sphere. Okay. Next. Like that, for need these values are enough. Okay.
Yes, sir.
But generally there will be another formula. I don't think. Okay. Mostly this is enough.
Yes, sir.
And mains also. To some extent, they might ask you for advanced other disk, ring, and all. Now, two charges are
So
present.
that, sir,
Bully, tell me.
that plain sheet or infinite sheet, something was there, rods and all. It is not there, sir.
They are there. Plane sheet and infinite sheet are there. There.
Yes, sir.
They are there. They are there. I'll give you those values also.
I I thought they deducted in CBSE, sir, syllabus.
They deducted in CBSE.
I thought they deducted, sir. So I asked.
No, they are there. Then you take this ring, this one also. Ring also. Ring at a point P will be at a distance of x, which is having radius r. A ring. will be k q. K is 1 by 4 pi epsilon x here. K q x by, this one I'm taking to be x. K q x by the square plus r square whole power 3 by 2. Okay.
Yes, sir.
And its potential also you write here. Potential at that point also. Because potential, I'll explain that concept later on. K q by x square plus r square whole power 3 by 2. Okay.
Yes, sir.
So here you can write it. Electric field will be maximum at that value you can derive by differentiating it and making equal to 0. Electric field will be maximum at
Yes, sir.
x is equal to r by root 2. Okay.
Yes, sir.
Okay. Then here also you write the potentials. I'll explain you the potential concept. But solid sphere, here there's no place. Okay, I'll explain. But potential for hollow sphere is, that is, charge distributed over the surface or conducting sphere. If they say potential, these values I already sent you in that PDF. Okay, take in the PDF they are there.
That's some handbook, no, sir. That one.
Uh, that book, handbook. But one part here, the concept is important for the spheres. That's why I explain.
Yes, sir.
Potential, I'll explain again. Potential due to solid sphere will be k q by r. K q by r. Sorry, r outside the surface. Outside. Inside surface,
Yes,
that
sir.
potential will be k q by, as not inside, surface, on the surface of the sphere. That is k q by r. Okay.
Yes, sir.
Inside point, you know what is it? Inside point. You might think 0, right?
No, sir.
It is not 0. Whatever that is on the surface, that will be the same value, even the inside. Even if it is hollow also, the entire inside sphere, any point you take, the potential will be kq by r. Got it?
Yes, sir.
Like that. For solid sphere or sphere and over a charge distributed over entire volume, the potential at the outside point will be kq by r. We can consider the entire charge to be present at this point mass. So, but on the surface, kq by small r. On the surface also, it is kq by capital R. But inside point will be not that value. Which one? What is it? Inside point you took it as kqr by r cube, right?
Yes,
Here
sir.
inside point will be kq into 3r square minus 2r square divided by 2r cube. This is the formula.
Yes, sir.
This is the formula for inside point. Okay.
Yes, sir.
Did you know these values?
Yes, sir.
So here electric field will be maximum, and electric field we wrote, and potential also we wrote. Kq by
Yes.
x square plus r square whole power 3 by 2. Then for a long conducting cylinder, or rod, you can take it as q by, for outside point, by getting as distance r, for outside point r greater than or equal to r, you will get as q by 2 pi epsilon naught r. Okay.
Yes,
For
sir.
inside point it will be 0. Inside point it will be 0. E outside will be 0. Shall we go ahead?
Sir, in the inside point, it will be 0, sir.
Uh,
Sir, 1 minute, sir. I'll note down. Yes, sir.
Okay.
Yes, sir.
Then the values you need to understand. That long conducting sheet. Long conducting sheet, that will be E is equal to sigma by 2
2
epsilon
epsilon
naught.
naught. Yes, sir.
For non-conducting sheet, which is having surface, sigma is surface charge density here. Surface charge density.
Charge density.
Conducting sheet. For non-conducting sheet, non-conducting sheet it is conducting sheet it is sigma by epsilon naught. Non-conducting sheet it is sigma by 2 epsilon naught. Okay.
Yes, sir.
Non-conducting sheet it is sigma by 2 epsilon naught. For conducting sheet it is sigma by epsilon naught. Okay.
Yes, sir.
Then energy density formula also you can write. Energy density formula is half epsilon naught E square. What is? You might ask me, sir, why are you directly writing? Why are you not deriving these things? First thing is derivations are not required. Even if these derivations are required,
Yes, sir.
here if I derive you have to integrate and get the
Yes,
answers.
sir.
But for the symmetrical bodies, Gauss law is there, and using that Gauss law we can derive the things.
Yes, sir.
Got it?
Yes, sir.
Easily you can derive. How that Gauss law you can derive is, suppose if this is there,
Sir, 1 second, can scroll down, sir.
okay. These values using Gauss law can be easily derived. So that is why when you are preparing for competitive exams, I don't want to make it difficult for you to just derive these things. You need
Yes,
to
sir.
know how to apply. Okay.
Yes, sir.
Then, so this is a topic for potential. I need to explain, right? I gave
Huh?
values.
And
Potential,
what, sir?
potential, electric
Potential.
potential,
No, sir.
electric potential. Electric potential is nothing but potential energy per unit charge. Okay.
Yes, sir.
If you want potential energy, multiply that with Q. Got it? That Q which you kept there at that point. Potential is nothing but suppose a point charge is there. What is the potential at this point in this region? P due to this point charge is nothing but what? KQ by R. Got it? So you want
Yes,
potential
sir.
energy. What you need to do? You need to multiply the charge that you will keep here. Got it?
Yes, sir.
For unit charge, the amount of, simply to say in definition, the amount of energy required for you to bring a charge from infinity and to place this place here, I'll tell you the amount of energy you need to do, or the amount, the work you need to do to bring a unit charge to keep in this point is called as potential.
Yes, sir.
For unit charge, how much work you need to do to keep it here, that is potential. Why am I saying that is potential is, suppose you are trying to bring a charge, this charge will repel, right? Isn't it?
Yes, sir.
So this charge will repel means you are trying to do work against the force, right?
Yes, sir.
Got it?
Yes, sir.
So you need to do work against this force, right?
Yes, sir.
That work is stored as potential energy here. Got it?
Yes, sir.
Again, block you say here. You try to take the block upward direction against gravitational force, which is downwards, right?
Yes, sir.
You need to do the work against this force. So that's why that is stored as potential energy.
Yes,
If
sir.
it is 1 kg mass, that is potential. Got it?
Yes, sir. Means that amount of work we need to give, no, so that is what is potential energy.
Here also the same thing. For unit charge, that is potential. For Q charge means you will get KQ, Q and Q2 by R. Okay.
Yes, sir.
But ring is there for suppose here 5 coulombs of charge is kept. This ring
Yes,
is
sir.
of having a charge of uh, uh, 10 coulombs. So if I ask
Yes,
you to
sir.
find out what is the potential energy of this system, you might what you might end up is you should not use KQ1 Q2 by R formula. Okay. Ring
Yes, sir.
formula I gave you, right? What is the formula for ring potential?
Ring.
There is
You
a
gave something big one, sir.
uh,
1 by 4 pi epsilon naught q into 3r square minus r square.
1 by 4 pi epsilon naught into
3r square minus r square
that is not
divided
for
by
ring.
2r cube.
That is not for ring. That is for solid sphere.
Ah, yes, sir. That is for solid sphere.
Ring, what is the value?
For ring, kq divided by x square plus r square whole to the power of 3 by 2.
No. Is it 3 by 2?
Yes, sir.
Half. That is field kqx by r square plus x square whole power 3 by 2 is field.
Yes,
Potential
sir.
is power half. Did I give
Okay.
you 3 by 2?
Yes, sir.
You need to change this half. Potential is
Okay,
half.
sir.
For field is 3 by 2, power 3 by 2.
Okay, sir.
But field is kqx by r square plus x square whole power 3 by 2. Potential is kq by x square plus r square whole power half. Here, got it?
Yes, sir.
Potential into this charge, VQ, is the potential energy. This charge is 5 coulombs, right?
Yes, sir.
Like that you will take. So this Q is how much? 10 coulombs you substitute and you'll get the answer. Got it?
Yes, sir.
If you know the potential, you'll get the potential energy easily. Okay.
So what you told, sir? 5 coulomb, 10 coulomb?
5 coulomb charge is kept at this point and this entire ring is distributed out 10 coulombs. What is the potential energy of the system? What did we do? Potential we found out at that point due to this ring and multiplied that by this charge Q2. Then we get the potential energy.
Yes, sir.
The potential, what is the potential? K into this Q by x square plus r square whole power 1 by 2. Got it?
Oh, yes, sir.
This potential into
Yes,
at
sir.
this point, which is
Got
a
it, sir.
distance of
Got it,
x,
sir.
into this charge is 5 coulombs. Multiply, you will get that energy.
Yes, sir.
Like that, if someone asks you, a solid sphere is there, it is having a charge of 10 coulombs. So now another 5 coulomb charge is there, which is at a distance of 10 meters from the center. Then what you can do, 10 coulombs at the center you can assume because it is outside point, right? The
Yes, sir.
potential is kq by r, okay?
Yes, sir.
Into this charge is 5 coulombs. So this
Yes,
k
sir.
into 10 coulombs by r is 10 meters into this
Yes,
5.
sir.
So you will get
5.
5 twos are, so 2 fives are. So that is
5Q.
5k.
5K. 5K.
5k. K is nothing but 5 into 9 into 10 power 9. That is
Yes,
45
sir.
into 10 power 9.
Yes.
Uh, 40 to 10 power 9 newtons. Got it? So not
Yes,
newtons.
sir.
This is potential. Potential is joules.
Yes, sir.
Got it?
Yes, sir.
So this is the concept of potential energy. If you know potential, you can get potential energy easily.
Yes, sir.
But point charges it will become easy. KQ1, Q2 by R. Because KQ1 by R is due to one charge, field potential, and multiply with that Q2, you will get the potential energy of the two particle system. Got it?
Yes, sir.
But if someone asks you, there is n particles, 1, 2, 3, 4. So what is the potential energy of the entire system? What you can do is
1 by K into Q1, Q2, Q3,
uh,
Q4 by
so
uh,
K into Q1, sorry, Q1 by Q1 Q2 by R1 2 plus Q2
okay.
Q3 by R2 3 plus Q1 Q3 by like got it?
Yes, sir.
R3 1 plus Q1 Q4 by R41. 4 charges are there, so you'll get 6 values. 1 2 you got, 1 3 you got, 1 4 you got, 2 3 you got, 2 4 you need to get. Q2 Q4 by R24. Distance between R2 and second charge and fourth charge. Then another value you have to get. 2 3 you got, 3 4. Q3 Q4 by R34. Got it? So you need to add all the values to get the potential energy of the system. You need to add all the values. Got this? Did you understand, Nivas? 1 minute. 1 minute.
Sorry. Got it, sir.
Did you understand?
Yes, sir.
So this is the potential U1, U2, U3. All you add, you will get the total potential.
Yes.
Okay, this is about
Yes,
the
sir.
story about potential energy. And so next class we'll discuss about electric field,
Yes, sir.
and we'll directly go to electric field
Capacity.
and dipole, and we'll go to capacitors. Okay,
Yes, sir.
thank you.
Thank you.